So I kind of covered some of this, 40 years, and you'll see these pictures, and we'll kind of go over it a little bit longer. This was an addition, the dome was an addition to these silos over here. All of those silos you see here, that one single dome stores more product than the silos combined. And we'll show you the concrete that was used. I know that the world of cement and fly ash, and it's being regulated heavily. And we're always under a microscope trying to say, we need to become more green, we need to become more green. My attempt with each of you is, you guys talk to other people in your company. We think we're a solution to help a company establish, get more carbon credits, and become a more green company. The dome is a solution simply because it doesn't take very much concrete to build a dome. So how can we reduce your carbon footprint? This right here, this storage facility was previous to when we put a dome in right over here. We were able to build a dome that was approximately 136 feet in diameter and 120 feet tall that held the same amount of product as those 3 flat storages right there. Simply because we can stack it against the wall right to the very top. Same here. This was a smaller dome that we used. This one is in North Carolina. This is also in North Carolina. Some of you have probably been to this site. Savage owns it now. But it's the Carolina Marine Terminals at CMT. So how do we've got climate change, we've got all of these things that we have to worry about as we are getting these residual products from these plants, and how do we get these offset credits and reduce our carbon footprint. With a dome, obviously, we can do a lot more with less. If I could take each one of you into a dome, I would love to do it because it's a little bit overwhelming. This is a wood pellet dome that we built recently down in Panama City. This long storage right here and this dome right here hold the same amount of product. So they both hold about 30,000 tons, metric tons of wood pellets. Why is that? I've been inside this facility. This facility, this has got wood pellets over here. None of them are against the wall. They can't be, because and they do have quite a combustion issue in there. They have to keep it ventilated, make sure it doesn't explode. This building has actually burnt down once, as well as some others. When you get into a reclaim system like this, 70% of the reclaim in this dome is done naturally. We don't have to take a loader in there. We don't have to move the product around. And it's the same thing with fly ash. It's the same thing with cement. We have the ability to minimize the impact on the ground and on the world. Let me go back one step. This right here, it was 70,000 tons that we put inside this dome. I think this dome was about 150 feet in diameter and nearly 135 feet tall. The silos next to it, those plus the smaller ones off to the side there, held about 70,000 tons, 70,000 ton capacity. So which one is greener? In order to build those silos, they needed about 13,000 cubic yards of concrete. The cement required to produce that concrete was 4,000 tons. And then the reinforcing steel almost 1,700 tons. You can see the comparison in a dome. Well, how does this all attribute to being more green? We have less concrete. So you think back all the way through. Less deliveries, less fuel, less forming, less material, right? We have less steel, which is also less manufacturing, less shipping, less delivery, less install. The labor is less. Carbon, 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 which we all know we need to worry about. When Prabhu asked us to give this, we actually gave this pretty close to the same presentation 2 years ago at EUEC, and I realize a lot of this is a sales pitch, and I'm hoping somebody runs back to their guy and says, hey, I got a solution for that, all of that reclaim that we have to do on that fly ash. But we do think we're a viable solution. Labor, we tend to think there are lots of ways to get these carbon credits. and lots of ways to be more green. You have less commuting, less housing for your labor force. These are all ways that you can submit to obtain more of those credits. Your capacity, your flexibility, your stability, more capacity. They're a lot easier to fill. Almost all of them are automated reclaim systems. I'll show you some of those reclaim systems right here. This is how we build the dome. We build a ring beam. We inflate it. That material in your hand is really mostly a roofing material. We have a company in Canada that makes this. We give them our specs. They design it. We roll it out. We hook it onto the ring beam. We do that with little clamps all the way around. This is the ring beam and those stud bolts sticking out. We hook it to the side with those little C-clamps right there. And then we take a building. There's a foundation there, and usually overnight we try to do it when the wind isn't blowing for obvious reasons. Overnight, people will drive by and all of a sudden it looks like the dome is complete because we do the rest of the construction of the dome from the inside, not from the outside. So it goes from that to a 150-foot tall structure overnight. As people drive by, they wonder where it came from. Excuse me. After that, we polyurethane foam the inside for two reasons: try to stiffen up the membrane, and also gives us the ability to attach our first round of rebar, which is your pre-mat right here. They're attaching that to the foam, and then that gives us the ability to hang our structural rebar, which can be anywhere from an 8 to a 12. That means that's rebar about that big around, some of it close to 1.5 inches in diameter. So we'll use 800 tons of rebar in the dome. That is a single mat of rebar, of reinforcing, or in Australia they call it Rio instead of rebar. We are currently building two domes. One we just finished in Adelaide, Australia, and the other one we are building, just starting on location a month ago in Perth, Australia. Then we spray shotcrete. Shotcrete is concrete with small aggregate in it that will go through the nozzle of a high pressure hose. And we do that over and over and over again, and we were able to accomplish and get these domes built in anywhere from 3.5 to 6 months. So you have a facility that needs storage and they need it fast. We are that solution. So all of that plays into that green. And then there's a lot of different kinds of reclaim. We can do screw systems. The most common in the ash business right now, maybe some of you have seen this, it's an aerated floor. We literally fluidize the ash. The floor is on an 8-degree slope. And so we can do this in sections with a PLC. So the whole purpose of fluidizing that product is to get it to avalanche, and it will flow like water. It's fascinating to watch it flow. We put it into some kind of a pneumatic pump, usually an FK pump of some sort, and we load it into wherever we need to load it, trucks, rail, or whatever. This one here, some of you are familiar with DCL. I know some of you have DCL equipment on your facilities. And then this one right here is one of the ones in New Zealand. It was also a DCL floor system. This is an FLS. I see FLS is here, a different division. This is fabric. Underneath there is an air channel. We put the air inside there. It goes up into it starts to bubble, essentially, the fly ash. That fly ash literally looks like it turns to water and flows down to the exterior of the dome so we can put it into the pump. This one is a vacuum system. It works very similar. Those are air slides. But that center tube right there vacuums the fly ash and sends it out. This is a nice option for somebody that already has a flat storage system that can't put a slope floor in there. Also helps eliminate weight on the ground because it seems like most of these fly ash places don't have really sound soils, and it takes us a lot to get down to the bottom. Other than that, these are completed domes. That one's in New Zealand. This one here was in Newburgh, Maryland. This one's been around for quite a few years. It's plant fed, has a truck loadout. This one's Buck Station, North Carolina. 30,000 ton fly ash dome. right there. This one's in North Carolina as well. Cape Fear. And then we have a few cement domes around the world. That one is in Alaska. So other than that, we feel like it is a solution. Do any of you have any questions? No quick, fancy scientific questions.
What's your limits?
Pardon me?
What size limits do you have?
How big? We've built 120,000 metric tons. We'll hold 120,000 metric tons of fly ash. If somebody came in and said, we want one that's 350 feet in diameter, we'd probably go, we don't have to do that. But the biggest one we've built so far today is 230 feet in diameter and near 200 feet tall. So there's two shapes we build. Obviously, a hemispherical shape, perfect half of a circle, is our strongest and least expensive to build, right? It's been about 10 years. We started figuring out, hey, we can go up with these because we had people say, I only have 150 feet of real estate to work with. That's all you get. So then we started realizing with a little bit of engineering help, we can do a cylinder wall and put the dome on top of it. Nice part about the dome versus even like a, for instance, in Colonial, some of you might be familiar with that cement plant down in Savannah, Georgia. You got 18 silos right there that are 200 feet tall. Our single dome is going to hold more cement. It's right next door to them. It gets 135 feet tall, the dome, and it will hold more cement than those 18 silos combined. So you can imagine, we're not a solution for everything, but we are a solution for quite a few things. So there is a limit. We've never experienced a limit yet. So nobody's actually. Any other questions? Okay, I got you out of here way early. Supposed to be here till noon. I don't know what time it is, but it's probably about a quarter after before you close. Thank you. If you have no more questions, I appreciate you being here. Yeah.